when I joined Ocado, it was 2,000 employees. We developed a big automation stack, and it grew to, when I left, it was 22,000 people. We've picked raspberry because it's probably the hardest fruit to pick, right? Our journey is to be able to pick any fruit, but raspberry, because it's so soft and easily damaged, it's quite an engineering challenge. And we have no competitors in that area.
Sid Shaikh has spent 25 years in robotics and automation. He built the engineering team behind the Ocado smart platform. He managed 140 engineers and a £19 million budget. Now, he's CTO at Fieldwork Robotics, a 15-person team in Cambridge, building a robot that picks raspberries in live commercial farms. Last year, they ran a 6-month trial in Australia. The client actually sold the fruit the robot picked. Most agri-robotics companies are building strawberry pickers. Raspberries are softer, more easily damaged, harder to reach, harder to grip without destroying the fruit. The field environment changes every single day. Fieldwork chose raspberry deliberately. No competitors, no playbook, no one to copy. And that is exactly why Sid joined.
We only need to pick one berry every 48 seconds to actually hit the return on investment of less than 2 years for our client.
Then comes the part of Sid's career that does not appear on conference panels. Prior to joining Fieldwork, you were at Hypertunnel, which unfortunately went into administration. That's pretty rough. What did that period teach you about kind of business reality versus, hope, engineering hope?
For me, what I learned was I was head of robotics there, and I was developing the robot platform. But I think other areas of the platform weren't as advanced. And I think I said it earlier. When you join a company, look at what's the problems I always almost work backwards, right? What's your end game? What do you want to achieve? What's going to give you the best commercial outcome?
This episode is about the gap between engineering progress and commercial readiness, about what happens when one part of a product races ahead while another part does not. And it's also about what keeps engineers going when the problem is genuinely hard.
You don't really want to turn engineers off by getting them to work really hard on something and then it never gets put into production.
This is Why Design. Sid, welcome to Why Design. Thank you so much for joining me. We're going to go through your journey shortly, but we're just going to dive in. So, Sid, you've spent 25 plus years scaling robotics and automation. You've worked at GSK and Ocado's, like 3,000 robot warehouses, and now you're CTO at Fieldwork Robotics, building a raspberry picking robot in the real world and not a lab. But before we get into all that, into your background, I'd like you to take me back to a moment where everything shifted. And what's been the most kind of this could all go wrong moment that you've had so far at Fieldwork?
I guess it's something that's happened quite recently. We've been making lots of it. We had a 6-month trial in Australia with our robot picking in a real pick environment, and they actually sold the raspberries that we picked. We were making lots of improvements, but we weren't seeing the improvements reflected in the robot performance. And we went away and we did some analysis. We pulled a lot of data during this trial, and one of the bits of data was trying to understand the environment that the robot operates in and performs at its optimum. So I guess what we typically used to do was rock up at a farm and deploy the robot and hope that it would run. We looked at what's the maximum, the taller. I mean, this might sound obvious, but we looked at the highest berry, the lowest berry. What can the robot reach? The closest berry, the deepest berry. We looked at all of the obstacles that might get in the way, and we did a calculation and we worked out that actually the amount of berries that we could reach and the amount of reachable berries that we could pick was very low. and that explained all of the reasons why we were making all of these great improvements to the vision stack, or the robot motion, or the way that we target berries, but it wasn't showing an impact in performance. And it's been a real light bulb moment, and we've just incrementally nailed down. We've increased the height, we've increased the depth, we've changed our pick strategy, and now we're starting to see real improvement in performance.
It's pretty challenging as well, isn't it? Because I think you're in 3 countries. Australia probably been the furthest one away. So have you got a full-time team out there, or is it a case of going out for each deployment, or letting the customer or the user set it up under your guidance?
Our main base for engineering is in Cambridge in the UK, but that's a big challenge for us because the harvest season for raspberries is only 5 months, and we're trying to work on developing a lot. We do a lot in simulation, but we're developing a fake raspberry bush that mimics a plant more closely. So we have a fake bush, but when we run a trial, the robot passes every test. Then we deploy it in a real raspberry lane, and it fails all of the tests. And we need to bridge that gap. We want to be able to deploy robots and then work within days, not within weeks. So we have I've got a team of five engineers in Portugal as well. But again, not that close to the raspberry farms in the south. And then, as you say, in Australia, I had one guy working there full time. Now that we're not running that trial, we've ended that trial. He's back in the UK. But the great news is that that client wants to extend the trial, so they want to do another 2-year program, and it'll actually be a revenue generating program. So it's very exciting for us. We got paid for the first trial, but it was not a lot of money. The 2-year trial is really exciting for us because we'll run it as what we call harvest as a service program. So they lease our robots and we run it and we charge them per kilo. So very exciting.
Yeah, wonderful. I bet when you were studying robotics back in the 90s, you never envisaged having to develop a fake raspberry bush.
Well, I guess that's what's exciting about robotics and automation. I thought it would be 6-degree or freedom arms that were picking and placing automotive parts or something like that. But the diversity I've had in my career is really phenomenal, and I really loved it.
Yeah, no, it's amazing. Well, that segues really nicely into kind of what used to be my first question for guests, but that's why design? And in your case, why engineering? Why robotics? What drew you down this path kind of in the first place all those years ago?
I studied a robotics module at university, and I really loved it. And I guess it's carried on for me. It's the mix of all the different engineering disciplines. So I've worked with the standard mechanical, electrical, electronics, software engineers, then vision engineers, scientists, process experts, chemical engineers. You get to work with everybody. And it's a combination of all of those different disciplines. And then you can't help but, if you're working alongside a biologist or a chemist, you'll learn about their processes, and you have to deploy successful systems. And as you learn and you grow your expertise, you can apply quite a lot of what you've learned laterally across industry. So I've worked in most industries, and I find the cross-fertilization of knowledge really exciting as well.
Absolutely. So when you did your master's in robotics back in the early 90s, what did you think robotics would become, and what did you get absolutely, totally wrong?
I've always worked for UK companies. I always expected the UK adoption of robotics to be a much higher ramp. I'm surprised at how little automation is deployed in UK factories. Um, I mean, my learning is that when people think of um, robotics automation, they think of shutting down the whole factory, making it lights out, and making it all robots. But my past history, even in my early career, I've deployed one little piece of automation in a very manual process and made a big impact in a business. So um, I expected to see a lot more businesses with maybe not full automation, but some automation.
Mm. Yeah, interesting. Because when you do see it, you see those little pockets or the robot cell, it's really impressive. You can see that, that investment is clearly going to pay off in just in terms of lead times, but also, the cost, and you can run, um, autonomously, but you still need people, don't you? You still need, machines
People and
need
automation
maintaining,
mix very well.
Yeah, absolutely. And we'll get onto it later on in more detail, but you said to me when we prepped for this, you don't see your machine as a replacement for farm workers and labourers. It complements it, augments. If I've got that right, but
Well,
yeah, I think
I've worked in lots of businesses where they've implemented automation, and the business has grown. When I joined Ocado, it was 2,000 employees. We developed a big automation stack, and it grew to when I left, it was 22,000 people. So
it's
I don't
nuts.
know how many it's grown to now, but um,
Yeah.
that's the opposite story. And I worked in the underground construction industry where nobody wants to work underground in the dark, and the safety record isn't great. So it's quite dangerous, quite a dangerous environment. So if you remove people from those horrible environments and those horrible jobs and those unsafe jobs, then I think it's the right thing to do. And with the fruit harvesting, our biggest client is and our biggest pull and the biggest pain in the industry is in Australia, where people don't want to pick, so they can't get the labor. So they're flying them over from all over the world, which has got a terrible carbon footprint as well. And they're having to house them on the farm, and we're not putting people out of jobs. We're trying to, I guess, what we're trying to do is stop raspberries being like £10 a punnet or £20 a
Yeah.
punnet. It's yeah.
Yeah, really interesting. Really interesting. So, let's talk about some of those kind of pivotal moments throughout your career then. So, every career's got a few make or break moments. So I want to dive into some of yours, Sid. You just mentioned Ocado. When you joined that business, you obviously come with your track record in robotics. Were they already doing robotics then? Because a lot of people know Ocado as the retailer. I guess a lot of people that listen to this will obviously know that they're a massive robotics company now as well. But what were they when you joined? And were you privy to the decisions or internal arguments that kind of forced that shift from retailer to global robotics platform?
When I joined, they were an online grocery company, so they had quite a big software team. They were very good at buying off-the-shelf equipment, typically conveyors, tens of kilometers of conveyor in a facility, and controlling it with very clever software and eking out highest performance. They had quite a few forays into trying to develop technology and move into robotics, but unsuccessfully. So my journey there was to I built the team that developed the Ocado Smart Platform. We developed the first site, so I think we developed something like 200 products, and built the site and furnished it with automation in 2.5 years, which is very, very fast. Something like 200 products, from totes to robots to the grid to the fire suppression system. We developed all of it. It was a very, very interesting time, and it was a very good learning, because there was a lot of commercial advantage in deploying the product early. So a lot of learning in deploying a prototype. I would call it a prototype into production. but very fast learning, very fast acceleration of the technology, and they used it to sell to the. I mean, I think they've got deals with 10 of the biggest e-commerce businesses in the world, and
Mm.
they used that Andover prototype in production to as a sales tool to entice other people to buy the systems.
So it's like a robotics showroom, is it, or a test track in some respects? Must be an absolute dream as a robotics engineer to have that big playground, I suppose, especially very different to your experience working in startups as well.
It was very interesting because at that time Ocado was seen as an online grocer, and people didn't. Even at that time, I would consider. I was surprised when I joined the company how high
Mm.
tech it was, but from the outside, people never thought it was a tech company. So it was very, very difficult. One of my
Mm.
biggest challenges was to grow the team and recruit engineers,
Yeah.
and to do a lot of marketing and try and um, the whole transitioning Ocado from a e-commerce business, an online grocer, to a tech company was very, very exciting.
Mm. Yeah. So, I mean, Andover's not an ideal location. I can't think of too many robotics companies out that way. So that must have been, you talk about kind of having to ship Raspberry pickers to Australia. Obviously, it's not as extreme as that, but still, location is a is the biggest barrier. When it comes to finding the right talent, and it could be as I've recently worked on a role out in Harlow, and because the business is a couple of miles from the train station, it effectively rules out anyone that's in London. Certainly, anyone that doesn't have a car. So um, what obviously I'm going to geek out on the recruitment side of things now, Sid. But what was some of the biggest lessons or things that you implemented that made your life easier when it came to financing? Because you recruited a lot of people, or as you both personally, but also as a business. They kind of all come from Andover and the surrounding area.
I guess it's flexibility. You've got to be very open-minded. I think you can't just read a CV. We recruited, and I still recruit based on behaviors and on attitude, right? So
Mm.
it doesn't matter what list of code or what list of CAD packages you've done, or it's more on your outcomes and your behaviors and how you respond in certain situations and uh, how you respond to challenges. Um, I mean, I've been really lucky. I've always worked in companies that I've loved because there's always a really difficult problem to solve. And I don't know
Mm-hmm.
if that's luck or I've chosen that, but I think if you can give engineers interesting challenges and you reward them for their successes, and it might be money, or it might be typically it's more challenging problems or more responsibility or accountability that
Mm-hmm.
engineers love. Um, and it's getting the recognition. So if you do some, I mean, my team in Ocado, they delivered quite a lot of the stuff people said couldn't be done, right?
Mm.
And we went to suppliers and they laughed at us, and the outcomes are there. And I had engineers that I promoted 3 times in 5 years because they were just doing such great work.
Mm. No, that's also, and I'm guessing just looking at where Andover is, because it's you're right out in the sticks there, aren't you? You've got um, Oxford, not a million miles away, Bath and Bristol. I guess you'd have been, whether you
Well,
employed a lot of Dyson,
all
but
the development happens in
yeah.
Wellingborough City, and well, it happened in Wellingborough City and Hatfield.
Okay,
Um,
so that's a bit easier then.
and now they've
Yeah,
gone and they've got development sites across the globe now. But
yeah,
Andover's where we run the kit, so
yeah.
it's mainly operational staff at Andover.
Got
And
you.
Andover's
Okay.
selected because of its location to road road access,
Mm.
right? So
Oh yeah.
um, the M25 and the surrounding areas, because
Mm.
that's what you choose when you're placing a customer fulfillment center.
Absolutely, yeah. No, really, really interesting. Before we get back to the episode, something most teams realize too late. Keyword matching does not build hardware. Experience does. At Kodu, we specialize in senior contract designers and engineers who have actually shipped complex products. People we know, people we've worked with for years, people we can reference confidently. We assess beyond the CV, technical depth, commercial awareness, ability to deliver under pressure. Yes, we can turn a search round in under 24 hours, but the shortlist is tight for a reason. If you need senior contract firepower that is properly vetted and fully compliant, message me directly on LinkedIn. Obviously, you've built a 140 person engineering org. You've ran a 19 million pound budget. And we've already kind of touched on this, but what was the thing that you learned about scaling teams that most CTOs only learn the hard way?
I guess it's the structure of the team. There's always a sweet spot to sizes of teams. So at Ocado, I remember being asked, what was the sweet spot for your team? And I think it was about 50 people. Beyond that, then the management structures got complex, the communication structures got complex. It got harder to get things done, right? So you have to be really careful about how you structure your team and the split between management, leadership, and technical expertise, individual contributors. I think the days of where you're just a manager, I think, are disappearing. Right? Everybody needs to have an expertise and be an individual contributor, and be an expert in their field and talk the language of their teams. Right? So, I think that's a big learning. It's there is the complexity, right? Juggling. Team leads or leadership and technical expertise is not easy. You have to be very skilled in prioritization, but growing people with those skills and I guess giving them safe environments to grow those skills. So we used to let people manage graduates or interns and then scale up and bigger teams and try give them like managing externals or managing suppliers or managing remotely or managing in other countries. You can grow your skill sets with a structured development plan, so people can learn those skills in a safe environment.
Yeah, absolutely. You got to have that that space to make mistakes and learn from them. So talk me through what the structure of a 50-person team looks like. If you're running that team, you haven't got 50 direct reports there, have you? Because that would be, you'd never get anything done. So what kind of levels have you got? How many, would it be 2 kind of managers, or talk me through kind of how that kind of split works?
In startups, I would say that even at CTO level, you need to be involved in the detail. You've got to make decisions. You've got to make priority calls. You've got to trade off. You've got to manage risk, and you've got to manage conflict as well. So most of the all of the products I've worked on there are contradictory drivers, contradictory constraints, right? So I would say you need a team lead or a head of layer, but they're still working on projects, and then you need as many doers as you can get into the team. I've worked in companies where it's an inverse pyramid. There's very few doers, and the management team is growing and growing and growing, and most people are spending all their time communicating and updating, and they're not doing enough. And for us, in the last companies I've worked in startup land, you really need to demonstrate value and progress all the time. So yeah,
absolutely, yeah. It's got to be that balance, hasn't it? So, and as you said, you've worked in big, massive corporations. You've worked in deep tech startups. What would you say is the biggest lie that each side tells each other or tells themselves about the other side?
Um, I guess in most of the startups I've worked in, you kind of push to communicate greater progress than you've actually made, right?
Mm-hmm.
And it's that ability to assess a technology and say, okay, this is the state you're in. This is the true state you're in. This is how far you are from commercialization. This is
Mm-hmm.
what you need to do. This is what you understand about your commercial space. This is what you don't understand about your commercial space. So I've worked in businesses where they're solving the wrong problems, right? You go in and they say, well, we're ready to go to market, but actually they don't even understand the problem space. And a lot of engineers will understand the pain of developing and developing and developing for something you don't understand the problem you're trying to solve.
Yeah.
It's typically a big waste of time.
Saw a
And
lot of
so,
that at CES.
yeah,
Yeah, I mean, I'm not sure what problem a backflipping robot is doing, or robots that are boxing. It's interesting tech. It's fun to watch, but what real world problem is that solving? But yeah, sorry, it's a very very recent experience I've had.
yeah. I remember early in my career, I was distribution manager for Panasonic robots in the UK, and we used to have I remember at Birmingham NEC had a stand where one of the robot arms was drawing little pictures, and it generated very, very little interest. And then we
Yeah.
switched the demo to it picking and placing electronic components, or tracing glue around a component,
Mm-hmm.
or picking and placing complex objects. That's I think customers sometimes they can't use their imagination. There's an extent at
Yeah.
which they can use their imagination to translate a demo into their actual application. So yeah, it's a very tricky area.
Yeah, absolutely, absolutely. There's one robot that I saw that was playing tic tac toe, or not noughts and crosses, and you had these foam dice with a 0 or a naught or a cross, depending on. So you play by placing that with the cross face up, and then it would look at the board and it would place and play the game. But if you cheated, you put 2 of the markers down, it had a meltdown. It didn't know how to react, which I thought was quite interesting. And then I
So you
played
were having a bit of
chess.
fun out there breaking people's demos.
Yeah, yeah.
I
So
must remember never to invite you to one of my demos.
yeah. Well, it's just how do they react? But
Yeah.
you don't. You can do all the testing in the lab and everything, but until the product's out there in the wild in front of your customers, everyone tells you this. You haven't really started your testing until it's out in the wild. So, and you guys are exactly the same, aren't you? You can simulate as many raspberries as you like, but until it gets out and the train's slightly different to how you'd anticipated it, that's where the real problem solving comes in, I suppose. But
Well, it's
yeah,
something
it's just
very,
just
very
interesting.
close to our hearts, because
Yeah.
our early prototypes, and I think this might be the same for many businesses. It's our early
Mm.
prototype was very hard coded. So
Mm.
you take it into the operational environment, and every time it hits an anomaly or an edge case, you've got to write another piece of code, and you've got
Yeah.
to reconfigure the stack. And so every error is a real disaster. And
Mm.
as you move to learning systems and generative AI, then and I think this is a journey that we're on. Every edge case becomes an opportunity, a learning opportunity, right?
Mm.
So you get to the point where you're deploying a pretty dumb product and it's learning, and you can put AI across the whole stack. So
Mm.
we've got robots operating in the fields, and we can put AI into the perception stack and detecting raspberries and ripeness, or we could put it into the how it moves and how it navigates around obstacles. We can put it in many different
Mm.
layers, and then everything is an opportunity. Every time you pick and you hit a new a new variety or a new environmental condition, you learn, you share it with the rest of the robots, and it improves. And that's what I find really exciting about where AI is going at the moment.
Absolutely, yeah, because especially when you've got so many variables as well, your robot could be lined up to pick the fruit, and all of a sudden there's a gust of wind that takes the fruit out of sight, and it basically grabs air, I suppose. I had that with not with the wind, but I was playing a chess robot on my last day there, and if you, I tried cheating to see, played a false move to see how it would react, and it tells you the right move, so it tells you what you've done is wrong and what you should do, but then it goes to move it again. But by this point, because the arm's so slow, I've already put my pawn back in its starting position, and it's just grabbing at thin air essentially. So but you've got to be able to, the machine's got to be able to learn from those experiences. And
one of our demos that I really love is we don't just detect a berry and then go and pick it. We do visual surveying, so we track it. And I when I first joined the company, I didn't realize why they were doing that. But when you pick a berry, you might pull quite hard, and all the berries around it are shaking.
yeah,
And demo we can do is we can move the berry along, and the robot will follow it and still pick it, and it's quite cool.
yeah, it's and I imagine, yeah, like you said, one of those unexpected things that actually is quite an interesting challenge to solve. So well, let's talk about, we've touched on it, but let's dive into Fieldwork Robotics. Tell us what you're building. Let's make Fieldwork Robotics make sense to a non-AgTech listener. Let's talk about the labor shortage, economics, the hardest route to kind of Raspberry complexity. So for anyone that doesn't know who you are and what you're building, let's go through it. What are you building? Why does it matter?
Okay, well, we've picked raspberry because it's probably the hardest fruit to pick. Right? Our journey is to be able to pick any fruit, but raspberry, because it's so soft and easily damaged, it's quite an engineering challenge. And we have no competitors in that area. There's a lot of people in in strawberry, but nobody else picking raspberry. So we've got a patented technology that picks the delicate fruit without damaging it. And it's basically what we call we've got a robot that's split into a base and a payload, and the payload sits on top of the base, and the base is the navigation around the farm. And we're base agnostic, so we buy in the base. Others have solved the problem of navigation around the farm, but it is a big challenge. So these are we can be working on a 150-acre farm, and there's the communications and infrastructure and the GPS, the RTK. All of that technology is quite challenging to be able to locate where you are and accurately run a robot down the middle of a lane and stop in a known location. So we buy all of that in, we put our robot on the top, and we do our value add, which is picking the raspberry. And we've got 4 arms running at the same time. And actually, our use case is quite simple. We only need to pick one berry every 48 seconds to actually hit the return on investment of less than 2 years for our clients. And that's just bringing the cost per kilo for picking down lower than it would be if you just used human pickers.
Really?
And
Wow.
That's our big driver, really. And our technology stack is basically we take a big image of a workspace, we detect all of the berries, we classify the ripeness. So right now we're just picking ripe berries, but in the future we've got a project coming up where we're going to be doing some forecasting. So we're going to say, okay, I can pick these berries right now, but come back into this zone, come back in 2 days and pick those. This zone, come back in 3 days and pick those. Right. So then you start. One of our big benefits is that we're capturing lots and lots of data, and we're not just capturing. A lot of farms have farm scale data, and they can calculate their yields. and when their yields are at a farm level, but we can do that down to a plant and if needed a berry level, right?
Wow.
So we can use this data to optimize the pick, but also optimize the deployment of human robot teams. So our product doesn't replace humans. We work alongside them. Our robot is never going to be able to pick all of the berries. Some are going to be hidden behind leaves, are going to be unreachable by the robot. So our journey is to probably pick before even the human workers have got up, or maybe pick when it's too hot for them to work. One of the big things about fruit picking the Australia has a 10 to 12 month harvest season, right? Because it's a lovely hot country. But imagine what it's like picking it under a polytunnel when it's really, really hot. It's not a very comfortable environment. So a robot doesn't care about that environment. So our journey is to be able to pick all of the berries, maybe low light conditions before the operators got up, and then them to pick the remaining berries afterwards, right? And we reduce the I guess my understanding is that depending on the size of farm, a typical operator might have to walk 10 kilometers a day, right? So we're trying to reduce that, and we're trying to almost be like a harvest assistant.
Yeah, no, that's awesome. So you mentioned the goal is 48 seconds, per berry. When
you think about it, that's a long time.
It is,
You've got quite a long time to pick a berry, and I guess our challenge is to make sure that we pick it successfully. If we spend a long time picking and we don't successfully pick it, that's where we don't hit our performance, right?
What performance are you getting at the moment on average? How long does it take to pick a berry?
We're picking, I haven't done the maths actually. We're picking, it's a lot quicker. So it's not how fast we can pick a berry much quicker than 48 seconds, but it's the success rate, right? And that's what we're driving. So our target for this year is 150 berries per hour. And that's across 4 arms. So,
brilliant. And you've got loads of metrics there that you can, as a CTO, you can geek over and improve. There's always areas to improve. So in terms of speed, but also, yield, efficiency. So wonderful. So, what was it that you've been there just over a year? What was it that attracted you to join Fieldworks? What was the pitch to you?
I'm very attracted to working in startups because small companies, they're moving very quickly. You can make a very high impact in a business, and you don't have to be CTO for this to be the case. You can be a junior engineer. You get to work on quite a broad spectrum of the business. You get visibility of quite a lot of the business. You get to understand how a business runs, and you get to make a high impact. And I think that's what's exciting. And I suppose my skill at Ocado was taking my journey was R&D, then robotics and automation, then production line, then product and scale up. So I did a lot of work in medical device and starting to make instead of making one a year, 10,000 or 1,000 a year, right? So I'm particularly interested in scale up and commercialization. So taking a company that has a prototype and wants to get revenue generation. That's what really excited me about Fieldwork and the complexity. It's got a difficult mechanical engineering challenge. It's got a difficult electronics challenge. It's got a difficult software challenge. It's got a difficult AI challenge, and it's got a difficult process challenge. So you put all of that together, and it's a very interesting engineering environment to work in and solve problems.
Absolutely. And what does the team look like today? So that this might differ by the time this episode goes live, but what does your team look like? From a headcount perspective, but also a skills mix.
So my team's quite small. It's 15 people. That's 5 in Portugal, 1 in Australia, and the rest in the UK. I've got mechanical engineering expertise. I've got 1 electronics engineer. I just recruited a really brilliant electronics engineer. Really gonna one of my big levers to pull is taking cost out. So we've had quite a big success. We managed to take more than 30% cost out from prototype to
Amazing.
first production unit, which is my 2028 target. So I'm quite pleased. And it means we can park one area of development and focus on other areas. So, but my electronics engineer will be developing some bespoke electronics and take even further cost out of the product and improve the reliability. We've got AI, vision, and machine learning expertise. We've got control software, so kinematics and motion, and we're on our journey for converting from ROS 1 to ROS 2. So we're doing a lot in ROS. We're doing a lot in simulation. We're also building I call it a digital twin, but it's multiple things. It's a digital twin. It's a fleet controller. It's a receptacle for all of our data. So we've got digital twin and simulation skills as well. And we got project management expertise as well.
Yeah, awesome. And in terms of you mentioned obviously the 30% reduction on the bill of materials. What might sound like an obvious question, but what impact has that had on the business? What does it unlock? What does it enable you to do? That you wouldn't have been able to do had you not saved that money.
It's multiple things actually. So I mentioned ROI, the return on investment. It means that it's one of the levers. So our levers for return on investment is uptime and reliability. It's the cost of the product that we sell. It's the robot to operator ratio, and it's the performance, right? How much we can harvest and how quickly we can harvest it, right? So pulling one of those levers accelerates our ROI or takes the pressure off one of those other commercial drivers.
Yeah, absolutely.
And it also means we can ramp sooner because our product is cheaper. So we're doing a lot of work in Australia because as I said, the biggest pull is in Australia, but we're seeing quite a lot of grant funding for manufacture out in Australia. So instead of being able to make 20 units, I can make 25 units, right? And one of the things I learned in Ocado is that the acceleration to the development is through deployment in the field and scaling. So you can accelerate your product quite significantly by putting it in the field, especially when it's a complex environment. I mean, the last industries I've worked in, some products you can test in the lab and you can very successfully test them. When I worked in underground construction, it was very expensive to test, right? You had to basically have a multi-million-pound site to test your product in. Ocado, you need a very big facility. We can't test in the lab. We're trying to offset that with making a fake bush, but we need to go to a farm and we need to run in a big lane. That's not easy. That's not cheap.
Yeah, absolutely. But like I say, without that, it's very difficult to advance the technology, advance the business, learn kind of where you can make savings, where you need to spend more time. You learn so much in real world testing. Obviously we mentioned fundraising right at the start of the conversation. But fundraising while building hardware, that's a special kind of stress, isn't it? But you're working with some AgTech investors, so they know the scene. But what's the part that non-AgTech investors underestimate most about robots in the field and kind of where they should put their money, I suppose?
I guess it's the journey, right? What we're trying to do is very complex. We're trying to picking a very complex, changeable scene. And I get the feeling that some people think that they're buying tractors, right? They're gonna, or a mobile phone. You take it out of the packaging and it'll work straight away. There's a journey, right? And you've got to, I think you've got to invest in that journey, right? And as long as you can demonstrate that progression, then I think it's a solid investment. I think the labor shortage is just going to get worse, right? And so I feel like some clients are kicking the can down the road, and then the sunset years are coming, right? And you got to plan ahead, and you've got to get on that technology journey. So for us, it's not just parachuting a piece of tech into a farm. It's the farm integration as well. It's very easy to deploy some technology and add cost, right? So we're lucky. We've worked with some our client in Australia, for instance, that they've come on the journey with us, right? And they've said, okay, we ran our 6-month trial, and both of us learned that actually we were trying to sell night picking to them as an additional feature, and they were saying, well, we'll have to keep all of the QC facilities and the pack house open for 24 hours instead of 8 hours. So then it adds cost, right? So then you've got to start thinking in a different way, and that's impacted our roadmap, and we found ways around that. But this is all very interesting learning, and it's how you make something a commercial success rather than just developing tech.
Yeah, massively. And on the team side of things, you're running out in Australia, you've got Portugal, you've got UK. That could be quite stressful at the best of times, but what have you put in place so that, the communication doesn't break down, it doesn't turn into chaos and just Slack noise, essentially?
We've used very simple tools and methodologies. We're agile. We have a morning stand up. We have team meetings with the software and hardware teams. And then what we're doing, I love demos. So we do sprint demos every 2 weeks. And we do a monthly catch up with the whole team. And we invite senior management to the demos, and we invite senior management to the monthly, but it's their choice. It's got two purposes. One, to inform the management of where we are, but it's also that the team can share their successes, their blockers. If somebody wants to, one of the beauties of startup is that you're working alongside a mechanical engineer. You've got a software problem. A mechanical engineer might have an idea for you, or vice versa, right? So the teams might make some suggestions, and you cross fertilize. So we're running sort of agile and waterfall methodology, but the daily stand-ups are really key for us.
Yeah, huge. Without, communication is the it can make or break a business, can't it, or any kind of team environment. So that's fantastic. And in terms of how you handling the Australia piece, because obviously the time difference there is quite challenging from a comms point of view. I'm struggling just with speaking to people while I was at CES, and being an 8-hour time difference. But how are you managing that side of things?
It's funny you say that, because I'm actually missing talking to the client out in Australia. I quite like talking to them, because you're learning so much. So we used to have a 7 a.m. call, but I'm up at 5 a.m. and I'm in the gym. So my challenge is to squeeze my gym session in before the call with Australia.
You have to do it on the treadmill.
Before we get back to the episode, a quick reality check. If you are building hardware, your next senior hire is probably the most expensive decision you will make this year. Get it wrong and you lose time, momentum, and sometimes investors. At Kodu, we work only with physical product teams. No spray and pray CVs, no bloated shortlists, just a tight group of proven designers and engineers who have shipped real products. Last quarter, we filled every role we took on. Average time to offer, 5.5 weeks. If you're planning a critical hire, do not leave it to chance. Find me, Chris White, on LinkedIn, and let's talk.
So, okay, awesome. Well, look, in terms of, successes, you've been with Fieldwork for just over a year, like I said. Has there been any moments or kind of times during this journey so far where you felt, you know what, we might actually pull this off? Was there like a light bulb moment for you so far at Fieldwork?
I think that's kind of every day for me because we were. I had an investor who reviewed all of the results from the trial in Australia, and they were asking us all of these questions on how we're going to improve the product. And I went through what we'd done in the last 6 months, and it's like I had to cut it shorter because there's so much the team have delivered. And when you list it all out, and it's very data driven, so it's we learned this, we verified it like this, so we tried this as a proof of concept, we tried this as a proof of concept, we've done this. The first phase of deployment is this, the end game deployment is that, but that's on the backlog. It was very, very structured, and there were innovations and improvements across the mechanical side, the vision side, the software side. So it's like it's really lovely when you get asked a question and you've always got an answer to it, or you've got you understand the journey. So a big part of my role is product management, right? And I said it to you earlier, right? I think a big turn off for engineers is if they're working on something, maybe they don't understand the problem or the commercial pull, and they're working on something that never gets deployed or goes in the bin. So product road mapping, getting the team to work with it, getting them visibility of clients and getting them to talk to clients sometimes as well, understanding the problem space, understanding what impact their work's going to do, what commercial impact it's going to have, and then making sure I don't like working on things that have in areas which have got a high attrition rate, right? So I want to work on stuff that adds value. So I think that's really exciting, and you don't really want to turn engineers off by getting them to work really hard on something and then it never gets put into production. I think that's very, very sad.
Yeah, and you can tell that just from speaking to you and in the previous conversations that really drives you, and it's it's remarkable. Really, you've only been there just over a year to have those wins, to see that journey and that ramp up. The owners must be delighted with you, and investors as well.
Well, we're about to start manufacturing out in Australia, right? And we're working with a company out there, and I'm very excited because one of the biggest challenges for scale up, or even for any company, whether you're a startup or a big company, is the early part of the journey, right? Where you're low volume. So it's the problem with suppliers, it's the cost of tooling, it's the NRE, it's how do you scale up? And we found a company that does design and manufacture, and they'll make 1 a year to 10,000 a year, right? And that's quite exciting for me. And they're gonna they're gonna take our design pack and they're gonna turn it into a manufacturing pack, and it's gonna be on a journey. It's not gonna be all in one go. We're gonna we ramp, it's quite an exciting time for us.
Huge, yeah. I want to talk about some tough lessons before we move on. Obviously, prior to joining Fieldwork, you were at Hypertunnel, which unfortunately went into administration. That's pretty rough. What did that period teach you about kind of the business reality versus engineering hope?
For me, what I learned was I was head of robotics there, and I was developing the robot platform. But I think other areas of the platform weren't as advanced. And I think I said it earlier. When you join a company, look at what's the problems I always almost work backwards, right? What's your end game? What do you want to achieve? What's going to give you the best commercial outcome? And then what are the biggest challenges, what are the blockers, and prioritize, focus on the biggest challenges and the blockers. Don't start from the where you are now and gradually, incrementally develop it, because a lot of it's easily solvable. It's what I call grunt work. You don't want to focus on that. You want to focus on solving the hardest challenge. And I think for Hypertunnel, I think the biggest challenge was the chemistry deployment, right? And 3D printing a tunnel underground, but getting it so that a client will safety certify it and be confident that it's going to stand up it's going to be safe, and it's going to have a longevity for 20, 100 years, right? That was the challenge. And so what I learned was I very slowly, I developed all of the platform, stabilized the platform, commercialized it for production for the robot, but I was very slow to move towards picking up the chemistry side and hitting the biggest challenges, right? And I think even if you're working in an area and you can see that something's not progressing, you can develop your tech and your scope of responsibility as fast as you like. If the team next to you doesn't if the horse next to you in the horse race isn't catching up, then you're not going to be successful. So I think that's a big learning for me.
Huge, yeah. Bro, well, look, let's not dwell too much on the past now, although it does play into the future. You know, what's got to be, if we're looking forward to the next 12 months, what's got to be true in that period for Fieldwork to feel inevitable?
I want to build my first production robots.
Yeah.
We'll be running a 2-year trial, and I think you hinted at it. You said fundraising and development is difficult. I think when you're a small team, production, operations, and development and mixing the two is very difficult. So we ran a prototype out in Australia, and my development team's availability just went through the floor because they were supporting the product, right? So it's all around. I mean, we've taken our product uptime from 10 minutes to multiple shifts, right? You don't before you had to follow the robot almost and titivate it. Now it can run down a lane and pick raspberries, and the operator can be somewhere totally different, right? So it's running in a production environment without any development happening on that robot. It's going to be a design frozen robot, and it's just going to pick, right? And so I'm really excited about that. We're going to do a whole load of work on forecasting. We're doing a whole load of work on our digital twin and our fleet control. And there's going to be quite a lot of AI and learning systems in there. So these are all really, really exciting for us. And then we start the ideation for our next generation of robot. So we learned loads from our first robot. It was kind of evolution. We sort of improved and improved. Now we understand the problems and the constraints of the current platform. We're going to develop the next generation. And
amazing.
Actually, one of the big things that I've learned, and it's quite exciting to me, and I've had to pivot the roadmap, is that our current robot will hit our return on investment. So it's, for me, I'm going to do a lot of strategy around when do I start working on the next generation. We call it the version 4. Do we need to develop it, or can I delay it and generate the revenue? That's the big challenge for us. But it's an exciting challenge.
Yeah, absolutely. It sounds like you've got your hands full, but it's exciting challenges over the next 12 months or so. So yeah, very exciting, and no doubt there'll be a ton of hiring at some point as well, especially if you're working on a new generation. So anyone that's listening to this, that's as part of that process, they should be pretty excited, I think. So wonderful. Well, look, we're going to we're going to wrap up with some quickfire questions. Just throw these at you. I haven't prepared you for this, so apologies. But just say the first thing that comes to mind, and I'll just say similar lines. So, the best advice you've ever had about leading engineers?
I'd say keep them challenged and reward their great work.
Awesome, great answer. A sign a robotics startup is heading for trouble.
I would say the endless prototype. So one low TRL to the next low TRL and no progression towards commercialization or design freeze or revenue generation.
Cool. And a habit you've developed that makes you a better CTO?
Oh, that's an interesting one. I would say it's discipline in communication, right? So for me, communication is really, really important, and it's up, down, left, and right communication. So keeping all of those ends of the compass informed. You can never. I've never heard anybody say you over communicate. So I think communication is key, and clear communication is important. Consistent, clear communication.
100%. Out of interest, and we're going off script here, but the stories that you tell, or the communication, paths, are they different depending on which direction they're going?
The level of content is different. I'd say the big difference is whether I'm talking to a technical or a non-technical person, right? I like my engineers to understand the system, not just work on their little tiny module. I like them to understand the full architecture and the full system. So and it's a learning opportunity. So they need to understand the jargon and the technicalities of the other modules and the other disciplines. So I think analogies and stories to help bring descriptions to life when you're talking to non-technical people. If you're talking to board members or investors, you really need to drop in some analogies and some explanations.
Yeah, and there's there's positive spin. There's telling it straight. There's it's the same story but kind of delivered slightly differently depending on who your audience is.
And you've got to avoid patronizing analogies because that's really frustrating.
absolutely, yeah. Right, back to my quickfire question. So, prototype versus production. What's the one sentence you drill into teams?
I would say that I don't like the term prototype, right? Because typically in startup, prototypes go into production and they get put operational. So there's a tendency to be lax and lazy with a prototype, and it will bite you. It'll come back and bite you. So if you know something is unreliable or isn't correct and you don't fix it, it's craziness. It's madness, right? Some things you have to prioritize, but you need to have mitigations. Otherwise, it's very easy to complain that you're not getting to do any dev and you're doing production support. But if you didn't fix it,
yeah. So if it's not a prototype, what are you calling it? The product? Are you calling it an MVP? What kind of terminology do you prefer?
When I develop a product, I like having lots of proof of concepts and their modules. But typically, we've got 2 prototypes in the field, right? So and the pull on those prototypes is phenomenal. So there's 5 or 6 different applications that you can use for the 2 prototypes. So it is. I guess it's the disciplines and the skill sets you use on a production machine. Apply them to your prototype as well, where you can, where it's reasonable. Apply them, because it will stand you in good stead when that prototype is in use.
Yeah, absolutely.
And I guess for us, data, right? If your prototype's inconsistent and unreliable, you're not pulling valuable data. You need consistency for that data.
Absolutely, yeah. And then final quickfire question: when you're hiring senior engineers, of whatever creed, whether it's electronics, software, mechanical, robotics, what do you look for personality trait wise or experience wise that makes them stand out?
It's behaviors and attitude and drive. So I typically look for people who can work from a blank sheet of paper. So engineers who've worked in the same field and on the same product and incrementally developed it, in the sort of pace of fear of change and the we have to pivot quite often, right? So every day's a learning day for us. We learn something, and then we have to be quite ballsy and say, okay, look, we're going to have to I know we put a lot of work into this part of the stack, but it doesn't work or it impacts this part of the stack and it's not going to work. So we're going to have to pivot, right?
Yeah.
And it's the ability to do that. So I guess it's that drive, that ability to learn, that ability to pivot, and the ability to roll with the punches, right? So if you're in, I've worked the last few companies I've worked in disruptive technology and deploying disruptive technology, and that means that there's nothing you can copy. There's nothing that's already out there. So you have to be able to draw learnings from other technologies or other industries, or you have to be able to do some experimentation, and then you have to learn and you have to be able to make a decision and move a design forward, right? People who aren't experienced in that or haven't got the right attitude will stall and they'll get stuck. And this is what I was talking about, the endless prototype, right? It's that ability to move something forward and then say, okay, this works now. I can park this and I can move on to the next challenge. And then it's like this, right? This is parked. I've moved on to the next challenge. We've got it to here. Now I've got to improve this. And it's doing that on a quite a complex scale is the sort of engineers that we love to work with.
Awesome. That seems like a really nice way to round it up. But on that, we've also mentioned that you're raising, you're going to be hiring kind of over the next kind of 12 months or so. So how should people reach out to you? If they're interested, if they've listened to this, you go, wow, that's a company I want to work for. Sid's a guy that I want to work for. How should they reach out? How should they get in touch?
Our website. We've got the roles on the website and the contact details. So yeah, go ahead.
Awesome.
Or ping me something on LinkedIn if you want, because
we'll drop the link to the website. We'll drop the link to your page on LinkedIn as well in the show notes. But yeah, really, really awesome talking to you, Sid, and going through that. I'm so excited to follow your journey. You've barely been there 5 minutes in the grand scheme of things, but you've achieved so much. So it's going to be exciting to see some nailing raspberry picking, and then what's next. I mean, if you can nail that, then it's the world's your oyster, so to speak. So yeah, wonderful. Thank you so much for being on Why Design.
Great. It's good to talk to you, Chris.
Likewise.